All right, hi. So, good morning. We're going to be doing two-step mole conversion problems today. Uh, so the way this is going to go, uh, this can be a little challenging. It's definitely something that some kids can struggle with. The one-step stuff that we did last week, that's reasonably simple, sort of. But then when we get into this, if you haven't been following along, or if the math is a little challenging, this can be where it gets a little confusing. So please, if you have questions, don't hesitate. Email me, ask questions. It's okay. Now, what I'm going to do one example from each of the assignments that you're going to have today. You're going to have two of them. And so one is going to be SP11. It's this one, moles of elements, two-step, and then moles of compounds. The big difference being one is elements, one is compounds. If you look at the actual problems, you'll notice like this one, it has like calcium. This one, it has like HCl, like more than one element. So compounds, elements. They're the same stuff. They're just the same process. They're just one extra step you have to do for the compound part. In addition to this video, I have several other videos that I've recorded previously in class that I'm going to upload as well. I'll upload these notes. So you should be all right. And, just know you're going to get two assignments today. It's 20 problems. It's actually a decent bit of work. Wednesday, you're going to get two more assignments, actually. It's a decent bit of work again. So two more, about the same amount. I think it's actually more problems. But then Thursday, there is no new work. Thursday is simply get all this done, the stuff from Wednesday done, and there's a short little quiz at the end. So Thursday's kind of like you're going to get all this work, but then like Thursday's like a catch-up day. So just know that that's planned in. Don't be freaking out thinking like, oh my God, well, I'm going to get more work Thursday. You're not getting more work Thursday. It's not. You're just doing all this. So let's go through and do some examples. So I think honestly, I'll just do. No, I don't like this first one example. I'll just make one myself here. So we're going to do a two-step problem. So this will be example. This will be for an example for SP11. So let's say you have 4.4 grams of, just to say calcium, whatever. We're going to convert that to atoms of calcium. So remember, this diagram now is going to be even more your friend than it was before. You're going to use it a lot. It's very helpful. It is very useful. I strongly encourage you to check it out. So in doing this, we are starting with mass. So we know that because we're starting with grams. So grams of calcium. So we're starting with grams of calcium, and it wants us to convert to atoms of calcium. So we're going to go mass. We're going to go grams. Now, there is no direct pathway from mass down to atoms. That doesn't exist. So instead, we've got to convert from mass to moles, which says we're going to divide by the molar mass, the periodic table mass. So we're going to look that up for calcium. Then we're going to go down. We're going to multiply by 6.02 times 10 to the 23rd, Avogadro's number, which again, remember, doesn't change. It's always that number. That's always what we are using at all times for these when we're converting from moles to particles, which atom is a particle in this case. Now the setup. This is where people get a little lost sometimes. So the way we're going to do this, it's the same idea, except we're just going to use a longer conversion chart here. So I'm going to write it out. I'm going to say grams of calcium. Now I'm going to do this all on one line because it's just much better, and that's the way you should do it. So grams of calcium goes down there. Remember, whatever unit you put here, it automatically gets put down there. So in this case, I'm at grams, and I'm going to moles. So my goal is going to be moles of calcium, which I'm putting right there. That's the thing to remember. And I'm going to go back and I'm going to fill in the numbers in a second. This is why the units are so important. It's so important that you write it out just like this. Now we're at moles. We're going to go to atoms of calcium, because remember, the thing it wants atoms of calcium. So you're going to copy moles down here. Remember, whatever you put, so so let's draw an example chart here. Like whatever you put unit-wise, you just copy them down diagonally like that. Okay, remember. So the units just always get copied down. So in this case, moles of calcium. And our final goal is atoms of calcium. So we're going to write that up there. Now, numbers. So to keep it simple for you right now, when you're just doing mole conversions like this without an equation, which you don't have an equation right now, we'll do that next semester. Mole will always have the 1 in front of it. So one of these two values is always a 1. Because remember, we're just converting. We're not actually changing a quantity. We're just changing the way we write the quantity or describe the quantity. But we're not physically changing the quantity. So one of these two things must always have a 1. So like 1 mole of calcium, 1 mole of calcium. Mole's always got a 1. Now in this case, we're going from mass. The first step is mass to moles. We're going to divide by periodic table mass. That's that grams right there. That's the division. So calcium, molar mass of 40.08 off the periodic table. So 40.08. So I'll even make a note. This is from periodic table. Now, next step, your moles, you're going to multiply by Avogadro's number, 6.02 times 10 to the 23rd. So 6.02 times 10 to the 23rd. And again, that doesn't matter what the formula is, what the element is. It's always Avogadro's number when you're converting to atoms or molecules, always. So, and again, this is just always. There's always that number. Actually, I don't want to write all this because I don't want you to think that that's always what you're putting there. It's not. It just depends. This is just the number. It's Avogadro's number. So, to continue, here, instead we'll just write Avogadro's number. Now, the math. This is where some people get a little, lost. Make sure your units cancel, your grams of calcium cancel, your moles of calcium cancel, you're good. As far as the math goes, here's what this equates to. This is the same thing as saying 4.4 times 6.02 times 10 to the 23rd divided by 40.08. Just so we know. This is the same as this. All right. So, you're just going to do the math. Make sure you multiply. I mean, in this case, it really doesn't matter since, it's all on the same level. So let's do 4.4 times 6.02 times 10 to the 23rd divided by 40.08. And you get 6.61, we'll say, times 10 to the 22nd. So there you go. If you just want to see it for a minute, you can pause it or whatever. So we'll say and our proper labeling and answer would be 6.61 times 10 to the 22nd atoms of calcium. That's what we have left. Now, as far as work goes and getting the answer right and all the credit and everything, this is what I expect. Everything inside there for credit to get full credit for the work. All right. So this is how you're going to do all of SP11. Though in some cases you might have to do a problem where it's not grams, where you might start with atoms. If you start with atoms, then everything's flipped around. All right. And the next example I'm going to do for 14, SP14, will show you that way instead. So there's this. Now let's do another example, but in this case, let's do for SP14. All right. So the big difference is that this will be a compound instead of an element. So we'll keep it simple. So let's say we start out with 20 grams. Or no, I don't want to start with grams. Because remember, I want to do this in the reverse direction. Let's say we start out with 7 times 10 to the 23rd molecules of water. So there you go. Let's say we start out with that, and we want to convert that to grams of water. So we want to know, you got 7 times 10 to the 23rd molecules of water. How many grams of water is that? Like, how many grams is that of water? What do we got there? So, basic setup of everything is the same again. You're going to start out, you're going to have, again, I like to take a lot of space. So you're going to say 7 times 10 to the 23rd molecules H2O. I abbreviate molecules MOLEC in a dot. I feel like that's easy. You can't abbreviate as MOL because that's mole, and you don't write MOLE because mole. So I just write the molecule. Now, the process in this case is reversed from what we saw before. In this case, you're going to go up. You're going to go to divide by. You're starting down here now with molecules, and you're going to go up, and you're going to divide by Avogadro's number. Then you're going to multiply by the molar mass, the periodic table mass. The big difference in this case is just simply that H2O is not on the periodic table. Like water is not on the periodic table. Instead, you're going to have to look up hydrogen and oxygen and add them up and then figure it out. So, yeah. So, anyway, let's do that. So, remember, you cancel out your units, so you'll put molecules of H2O down there. And the intermediary, you're going from molecules to moles. So moles goes on top, moles of H2O. Now, remember, moles to mass. So the next step is moles to grams, moles to mass. So moles goes down here, and our goal, grams of H2O. Now, for plugging stuff in again, remember, we can just put a 1 with the moles. Simple for right now. And then we know that 1 molecule, or 1 mole, is equal to 6.02 times 10 to the 23rd. That's what it always is. So we're going to put 6.02 times 10 to the 23rd. And then we know that 1 mole of water, well, we need the mass of that. So that's, again, moles to mass. We're going to multiply by periodic table mass. In this case, though, again, there is no water in here. So instead, we've got to say, all right, so we've got H2O. So that's 2 H's, right? Each H has a mass of 1.01. Did this, and I'm just trying to be really thorough showing you all of this. Hopefully this part's pretty simple for you by now. So hydrogen has a mass of 1.01. Oxygen has a mass of 16 right there. So, and then in oxygen, we've got one of them, 16.00. So that's 2.02 plus 16.00, 18.02. It's a pretty well-known molar mass. Like, it's oxygen or water. So, it's, hopefully you might already know that one. So I'm going to write 18.02 up there. That's 18.02 grams of water is equal to 1 mole of water. That is the molar mass of water, just taken directly from there. All right. So you'll cancel out your units. You're left with grams of H2O there, which is what you want. And pretty much now, let's show the math. So the math here in this case is 7 times 10 to the 23rd times 18.02 divided by 6.02 times 10 to the 23rd. You don't have to write this part. This is just me showing you what the math equates to here. Remember, you multiply on top, divide by the bottom. When you divide this, make sure that you put this in parentheses here, the bottom number that you put Avogadro's number parentheses. So that times 18.02 divide by parentheses 6.02. And you get that. So you get 20.95. So the answer to all of this, after all this, 20.95 grams of water. And that is, again, what I would expect in terms of credit. Like everything in there. Got to show all that. All right. So that's the deal. That's how you do two-step problems, whether it's an element, like I just showed you previously, or whether it's a compound and you got to do this, little calculation to find the molar mass. That's how you do them. All right. So, this Wednesday is going to be volume. It'll be more of the same. There's just Wednesday is just doing this volume concept. I'm going to show. I've got a good video that I recorded from class previously that I'm just going to show you on that one. I don't think I need to record a new one. It's the same concept as everything else, except you're using a different value now instead. But that'll be Wednesday. That's about it.